and do 13 and 14,
And then add them
and that's what we did. So just do it like that. I don't know why they did it like that, but that's, so 14 is in, and just use 13 for X and 14 for X and add them together. In other words, you gotta do 2 of them. But your P is what? The probability of somebody showing up, right? So that's gonna be point 9018. Somebody check me.
0.9018.
Dang old probability. 0.9018. So I'll go ahead and put one of them in. Second function, enter. 14. 0.90, insert 18. And
Why is it 90?
9018, because this is the probability that the person will not show up. 0.9018 and 14 or 13. So Stowe, where you buy your bread, alpha, and we'll call that the first number, so we'll call it F. And then second function, enter. Second function, enter. And change that to 14. I get that, plus alpha, what do we call it, F? Enter. I get 0.59. What does it say round to? Round to 4 decimal places. 5939. 5939. Now I got a question. If you were the person at the gate, you know when you go to the that place that has airplanes, what's it called? The airport. When you go to the airport, there's a woman, or usually, I'm sorry, there's an attendant there at the gate, you know, where you go and walk over that catwalk to the plane. There's a person there. Would you want to be that person with a 60% chance that that 13th or 14th person shows up? Then is it wise to book with 60% chance that they're going to show up? I wouldn't, but I don't know what their answer is. I know that mathematically the 0.5939, I know that's right, but I don't think it's wise to make that. I don't think it's wise with a 60% chance that they're going to show up. So, okay, let's read the question. Is it wise? Is it not wise? Oh, it is. I'm sorry. It is not wise. That's one I'm going to go with. A or what? D. Because the probability that there are not enough seats on the plane is point what? 0.69 or 0.59. That's what I would say. I would say is not, so overbooking is not. Okay, I think it's A. I think.
What's the rest of it say?
Says, so overbooking is not an unlikely event. Not an unlikely event means what? Likely. So, with 0.6, is somebody going to show up? Is that 13th, 14th person going to show up at 60% chance? Yeah. So, I think it's this one. A. I done forgot my number. I have it. 0.5939. Okay, find your mean and standard deviation. Let me go ahead and get it in the Excel spreadsheet so y'all can see it and we won't have to. I wonder if I just put it right here. I don't know if it's going to match up or not. Yep, I'm done. Y'all done? Oh, I'm sorry, I gotta punch it in the calculator. I'm being smart at it. Can y'all see it? Yeah, I can see it. That's the good thing about the Excel spreadsheet. You just punch it in, and it's got the same numbers, the same number of data, which it did. If you do it right, you ain't gotta do anything else. So did y'all come out with the same thing? Or y'all finished yet? I'll wait. Go ahead and call the roll on this. Bailey,
Here.
Bolt,
Here.
Clayton, Coward, Dutchke's here, Escobar,
Here.
Barr,
Here.
Freeman, Hammett,
Here.
Harris, Harvey,
Here.
Hayes,
Here.
Johnson,
Here.
Mullins,
Here.
Murray's here, Newton,
Here.
Poor, Perdesi.
Here.
Did you get that thing fixed, Mr. Perdesi?
Yes, sir.
What was the problem? Did they just, okay. Well, you need to see me after class. I need to check with you on some dates. Robinson, all three of them are here. No, got one missing. Little Robinson. Mahogany's not here. Right? I don't see it. Miss Scarborough is here. Schuler.
Here.
Simpkins.
Here.
Neves, I saw Dennis. I thought I saw Dennis. Oh, he's left. That is, yeah. Let's see. Dennis is here. Smallwood, not here. Both, no, one Vaughn is here. The other one's not. Williams
Here.
and Wood.
Here.
Okay, bureaucracy's done. All right, is that what y'all got? Okay, we're gonna move on. So mean is what we got to round to. Hang on. Round to 1 decimal place. So that would be 3.4 and 1.0. God, that was nice. 3.4 and 1.0. Next question. How is each unit test counted? All three forms. What I do with them? I'm thinking C. Just B. Will Hubert's final exam be online? What the heck is this? Oh, another binomial distribution. I'm sorry. Ted is not particularly creative. Ted sucks. He uses a pickup. Oh God. He uses a pickup line. If I could rearrange the alphabet, I'd put you and I together. The random variable X is the number of girls Ted approaches before encountering a slap. Before encountering one who reacts positively. Determine whether the table describes a probability distribution, so that means you got to check these to make sure that it equals what?
We can't see them.
I'm sorry. Hold on, Vanna's not doing her job this morning. I just had to get her the remote. Here you go. All right, what do you do to check to see if it's a binomial distribution? Add all the ones on the right, and all of them are supposed to be between 0 and 1. They all are between 0 and 1, but you need to add them up to check. 3 and 2 is 5, or 3 and 2 is 6, 7. I don't know, you're going to have to add them up and see. If they don't add up, then you don't have to do the problem. I don't think they're going to give you one of those, but we'll go ahead and copy, pull up our handy dandy Excel spreadsheet, and dang old paste. We got to change. Oh, they didn't put 0. Did they not put 0 in this one? No. Okay, that's fine. No, they didn't. Okay, so I got to delete this one. So let's check and see if this, is it a probability distribution?
No.
I can't believe I gave y'all this easy of a test. If y'all fail this test, do not tell anybody, okay? Just keep it to yourself. What's the only answer? When does the homework terminate? It's supposed to terminate midnight before the test, but I don't do that. I need to take that question out. Oh my God, not this one. All right. 12 households, 20%, none. So what would that be?
0.
Be 12, 20, and what?
0.
0. So second function, enter. Second function, enter. 12.2000. I'm just putting 4 digits in case we ever have a 4-digit one again. And 0. 0.06, round to 3 decimal places, 0.069. At least 1. So that means 1 or what? More. So I'm going to take 0.069 away from what? 1. And that's going to give me 0.931. Somebody help me out. Okay? At most 1. So what does that mean? You take 0 and 1 and do what? Add them together. So we got 0 right there. So we got to do 1. So take your handy dandy calculator. Second entry. And put a 1 right here. And enter. And you're going to add that to 0.069. I got 0.275. So that's 28%. If Find the probability that at most one household is, so we got 28%. What did they say? 20%. We exceed the 20%. So whatever that means, I have no idea if we're supposed to exceed or be under, because I don't know what it means.
It gives us the 0.5 thing on this one.
Well, if that's true, then it'd be 28 minus 20 over new minus old over old. So that'd be 28 over 20 divided by 20. So if somebody do that, I'll do it. 28 minus 20, enter, divided by 20.
0.4.
I get 0.4, which is 40 cents.
So it's less. Oh, no.
It's greater than, but I don't know what the answer is because I don't know I don't understand what a share is. I don't know, does that mean that we gotta exceed 20% or we don't? I don't know. So I can tell you that it's greater than 0.05. I'm just gonna say yes. I don't know the answer to that. I'm not gonna spend time on that anyway. I don't care if you get it wrong, just let me know. But you gotta let me know. 12 peas are generated from parents having the green, yellow pair of genes of peas. So there is a 0.75 probability that an individual pea will have a green pod. Find the probability that among the 12 offspring peas, no more than one has a green pod. So what's that? There's your one right there. So 12, 0.75, and what?
1.
Now it says no more than one.
So 0 and 1.
0 and 1. So you got to do 12.75, 0, 12.75, and 1. So do that. Second function, enter. Second function, enter. Second function, enter. Second function, enter. 12.7500 and 1. And well, we'll do 0 first. That's a small number. 0.000000. It's gonna have 7 zeros in it, right? I think we can pretty much say that's 0. Now, second function, enter. Dang old 1. That's 0 with 5 zeros and 6 zeros is pretty much what? 0. 0. I better put 0, 0, 0. I better put 0.00. Might mark it wrong. I don't know what this thing's going to do. Okay. Is it unusual? Well, you got 0 cents. You got to have 5 cents. So what's the answer? It's unusual. So why? Because of this occurrence is very what?
Very small.
Very small. Assume the probability of a child, of a girl, a child being probability of find the mean. Okay, let's find the mean. Let's take this, copy it. Dang old, take our Excel spreadsheet. Dang old, put it in. Did it copy everything correctly? Make sure.
Yeah, it's
Okay.
just there's you got an extra one, they didn't give you that many.
No, it jumped to 5. That's what I'm saying.
Oh,
There's only 3.
okay, there's only
0, 1, 2, 3. So I need to take it off. Y'all check my numbers now. Make sure that they're still decent.
Yeah, now it equals 1.
3. It does.
Okay. See what y'all get when y'all do y'all's. Y'all get those numbers? $1.4 and $0.9. Mean is 1.4 and the standard deviation is 0.9. I'm gonna leave that up there for a second. Is it unusual for a family with 3 children to have only girls? Well, 3 girls is, let's see, this is in terms of girls, right? Yeah. 3 girls is how many cents? 0.098. What is that? 10 cents, Hubert. That's right, class. 10 cents. So 10 cents is what than 5 cents?
Greater.
Greater. So what does that mean?
It is not.
It is not unusual, which means that it's normal. So is it unusual? No, because it's greater than what? A nickel. Your dime right here, I'm sorry, the 3 is 0.098. Well, that's a dime, 9 cents. Actually, it's 10 cents. And that's greater than 5 cents. So if it's greater than 5 cents, then that means it's normal. Okay? So we answered those questions. Next. Why does Hubert not entertain extra points, extra credit, and dropping any grades the last week of the semester? Why? Because he's awarded extra points like these on the test, and he drops the lowest 2 on each unit. And submit test. And we probably got wrong the questions that I predicted we would get wrong. What I made?
95.
Dang on 95. Dang on list. I bet you $1. These 2 right here. Well, did we have 3 of those questions? Yep. I have no idea what they're talking about. And I guess I need to sit down and read it. I don't know. But it says yes, because 7 households tend to. Okay, well that's great. How do they? There's a 66% chance. I'm not going to worry about it. Let's see what else did I miss?
22.
What?
22. 22 and 24.
Same one. Well, I'm not going to worry about it. Like I say, I'll make sure it's right. Oh, did we not? Oh, poo. You've got to be kidding me. Every one that we did, oh, because it's the 3 digits. That's the 3 digits right here. That's why they want it to 2 here. Okay. I would count all 3 of those right. So I'm not going to worry about that, all right? All right. So y'all good for chapter 5? All righty. Y'all have a good day. Somebody hit my button for me. And when y'all get back next week, we're going to get to chapter 10 in 2 hours.
It's the silver button.